And I love this provocative statement you said. Man, we need to start building data centers differently. Or maybe you said it in the negative, we're building data centers the wrong way. What do you, when you think about that, what is it that you have in mind?
Well, first of all, I'm a mechanical guy.
Okay.
I've been in construction all my life, but mechanical and electrical.
Okay.
And so I realized 25 years ago when I got into this that data centers are just big boxes to hold the mechanical, electrical, and the network. Mm-hmm. And to me, they've been built just fine for a long time. What I'm thinking about is the future. I don't believe today's designs are really right for where things are going because there's just so much big empty space. And that was okay in the cloud era because you didn't know what was going to go in the box. Mm-hmm. The data hall was adaptable to just about anything. You could put a 5 kilowatt rack or 500 5 kilowatt racks or 150 kilowatt racks, but it's things are different now. And I think that a couple years from now, we're going to have a lot of buildings that either need to be retrofitted or they're going to be suitable for old purposes and not new purposes. It's just a density thing. I respect those designers who are doing it. Corrigan, KW, those are fine firms, right? And everybody loves them, and QTS and everybody's building them. But I think where things are going, we might need to reconsider. I'd love to see inside Stargate, for example. I don't know what's in there, but I'd love to see inside it because I imagine that one's built the way I would perceive data centers should be. Yeah. Going forward.
Why do you think that?
It's a different purpose. It's a purpose-built AI data center, and there aren't that many of them around. I think you all might be involved in one or two, maybe more.
There are a lot of people in our industry that are having conversations with those folks. Yeah.
Yeah, but one of my philosophies is if you can get more out of chips processing, then you will. Right? We think that GPUs are just for AI. And CPUs are for cloud or whatever that might be. But I happen to think if you can use GPUs to do the internet, do the web, do whatever, that if you can use hot chips and get more performance out of them, then people will. And I don't see this performance trend slowing down or stopping. And I don't know. I'm not an IT guru, so I can't tell you whether the cloud would function well in a Blackwell array. But I think I just have a feeling that things are going to be a little different. I think we're now in an era where prefabrication makes a lot more sense, and the white space has really never been prefabricated to any huge extent. You prefab maybe containment, or you prefab some piping or whatever, but it's been too light, airy, not dense enough. You can't build it in a factory and ship it on a truck, and it will all fall apart before you get out there if you're building a cloud data center. But now an AI data center, it's so dense. There's so much material, so much pipe and wire and network, and it's all got to be supported in this massive structural infrastructure. You've seen the Smart Run and other people's similar products that they're selling these days. I just think it's perfect now for the white space to be prefabricated. So really that's what I'm talking about. It's prefab has happened a lot over the last dozen years. The UPS and switchgear boxes outside and whatnot, even the gear on the inside of some buildings. But the white space has been sort of off limits. I think the white space in the AI era is ripe for prefab, ripe for modularization. Right. And what form that takes, I'm not real sure, but I'm hoping to participate in that a little bit. I'm just really keenly interested in that. I took engineering classes in college, but I'm a horrible engineer. I've been a contractor my whole life. I couldn't get a job as an engineer, so I got a job in the construction business. Right. But I like playing engineer sometimes. I maybe sort of a closet architect. And one of the most enjoyable things about being in this business for so long is I get to help people design data centers. And so that's kind of my hobby.
As we're all sort of working through these challenged, or even our customers, you and I probably have very similar customers, are saying, I have workloads that serve the cloud, and I have other workloads that will be dedicated probably to a GPU world. And there's just not yet a way to integrate these things. So when you're having a conversation with us or trying to get us to open our mind and have an imagination, how do we face that conundrum where I need flexibility to accommodate whatever's going on today and maybe what the Fortune 1000 are trying to do, in addition to these really intense data hall large workloads that you're describing?
I think the challenge is if you're going to serve a bunch of different clients, a bunch of different end users with different requirements at scale, at large scale, you may need to have a diverse product line yourself, right? You, QTS, and others in the colo business need to have, this is your cloud model, this is your AI model, this is your telecom model, this is your edge model. And maybe you need to have a portfolio of types of buildings that you build and operate so you can cater to other clients. I think nobody really does that. In the last 10 years, everybody building cloud data centers has built the same basic 300 kilowatt or 300 watt per square foot kind of design. And some raised floors, some not, but there weren't a lot of differentiators. Most used air-cooled chillers, and so they have chill water now. Yeah. So that is a perfectly adaptable design for just about anything from low density to high density. I think there's a good reason to build those because it gives you the flexibility to cater to anybody. Yeah, low risk. But if you're billing by the kW or by the megawatt, and you can build a building 1/10 the size, maybe the return on investment is different. Maybe the calculation is different. The key is, do you have a customer that wants to take it for 10 or 20 years? And I don't know, are there customers willing to take AI data centers for 20 years? Maybe not. Yeah. Technology changes every 2 years, so I don't know if you want
to. The complexity there is I've got to be able then to, while in production, incrementally, not just deploy and commission, but decommission, which is its own level of complexity. So I don't know if that comes alongside the, maybe we're not designing, we the generic, not QTS, but we the generic, we need to design them differently. Maybe that will help resolve that.
Well, as somebody not in your business, but just a service provider to your business, I see people sort of angling in different ways. Some people are going extreme density and some people are not.
Right.
They're taking their course, they're taking their strategy, and they're going to design their buildings a little differently. That's kind of fascinating to watch. Yeah. I don't know where that's going to play out, how that's going to play out, but we will see.
Do you think is it just by workload? Is it by geographic region? Or is it risk aversion? Where do you think it's most likely to pivot and change the way you're describing, and the least likely?
I don't think we are the ones to decide that. My philosophy
not with that attitude. You should show up and tell them, Steve.
Well, what I mean is, no. I think that's what we've been doing for a while. The hyperscalers, the AI neoclouds, they're going to decide what they need, and you and I are going to build for them. And I don't know where it's going, but it could be going in a different direction than we've been going in the past. I remember asking somebody in your business about a year ago, what have you done to your designs to adapt to AI? And he said nothing. Really? I just thought that was a really fascinating answer.
Yeah.
Yeah.
I don't know how long-lived you would be if you sat in front of a big social media or e-commerce or cloud AI company, and they said, we're having to innovate and pivot in ways we never thought possible. We're asking people that have made their own silicon design, and they're giving it to us, and we're now manufacturing the chip. We see innovation in workforce and whatever, supply chain and all these other ways. What have you guys done differently? And they say nothing. I don't know that that's a long conversation.
I think the answer would be different today than it was a year ago. Probably it was different a month later. Things are happening so fast. Yeah. But the real innovation seems like it's happening in the hyperscale world. They may be doing it on their own campuses and then bringing ideas to you and saying, hey, I want to do this here also. That's my feeling anyway. I think Google, for example, has been doing liquid cooling probably for a decade.
Yeah.
That's my perception anyway. And so they're teaching people how to do it.
Yeah.
The rest of us are still trying to figure it out, but I think they've been doing it for quite a while.
Yeah. Oil and gas, chip fab. They're in it. I mean, when we were talking offline about our Richmond facility that we bought and converted into a data center. There was liquid cooling, world-class liquid cooling infrastructure in there when we bought it that could run didn't have a quantum computer, but they could run quantum computing at whatever that was, minus 20 C or something. I don't know. Like very sophisticated. So it's been around. We've done projects with research universities where they'll deploy a node, they would call them, in a variety of locations.
It's been around.
So we've done around, but it's at the speed and scale that we're talking about is the challenge everyone's working through. And so whether it's Google or whoever else has been thinking about it, and by the way, the people that were at that company 5 years ago or 6 years ago are now distributed. Plus it's like an NFL coach. That coach that came from Bill Walsh, sort of the Bill Walsh tree was Mike Holmgren and Andy Reid and all these other people that went on. And then they have their own proteges and they get distributed. Same thing.
The data center business is good for that.
Yeah.
A lot of great people start in one company and then they go to start 20 other companies.
Yeah. And they bring their ideas and what they're more willing to accept as change and, whatever. But that's why I'm curious. From my perspective, I see a lot of willingness to innovate and change. We're a fast follower. We stay close. But part of the innovation, at least in my mind, as we're designing data centers is like I was listening to one the other day that said, hey, look, if you want to deploy this many megawatts in this way, then I need to commission it differently. I need to be able to do commissioning, and they walk through a methodology, some of it off-site, some of it on-site. This is what we're posing. What do you think? On the one hand, as Bill Clayman quotes Peter Gross all the time, data centers love innovation as long as it's 10 years old. On the other hand, we can't keep doing the same thing, right, and expect a different result. So if we're going to move it, it's not just scale, it's speed.
Yeah.
And it's not just mega sites like ours, campuses. It's even in the what we would consider small data centers. 25 megawatts, 50 megawatts, and smaller. Which seems hilarious to say that that's a small data center, but that's a small data center these days. But it's innovation in materials, it's innovation in supply chain, it's innovation in financing, it's innovation in commissioning them, it's innovation in noise abatement, it's innovation in urban planning, and like all of these things, and they're not equally evolving, but they all have to evolve in order to build something that we think we can use for hopefully not a couple dozen years, but for hundreds of years.
Well, I remember talking to a design engineer recently, and he said they hope that the designs they're creating today will be useful for 5 years. That's astounding. And you, as a building owner, you hope that they're longer duration than that, but hopefully in 5 years they're adaptable to something new if they're not going to last that long. But it's just a crazy business. I've never, I've been in it for 25 years. You've been in it for a long time too. And there's never been this rapid, overnight transformation from something that was relatively normal, creeping up to something that's completely crazy, which we're seeing today. And there are opportunities everywhere.
Yeah. But that's the joy.
It is. I love it.
That's the joy.
I'm in my 60s. You just said you just turned 60. And I have more energy today than I had 10 years ago because there's so much happening in our business. I love it.
Yeah. If somebody once described, I've talked about it on here before, but it's one of my favorite conversations. I think it was on the Lex Friedman podcast. He was talking to one of the original engineers at Apple, and they were talking about Steve Jobs from a software development perspective. It was really cool. And this guy, I'm probably going to butcher it, but the way I remember it, he was talking about Steve's personality, not his vision, but his personality. And it could be pretty bombastic. And so sort of infamously, you might be pushing a cart full of stuff across the cafeteria from one lab to the other, and Steve sees you and he come over and like, what are you working on? And if you didn't like your explanation, you might not even have a job at the end of the day, right? So whatever the actual circumstances were, it was pretty rough. Everybody famously knows Steve didn't know it, but hired on his replacement, and he gets worked out of the business, and then gets hired back. And this guy's point was, why Apple started to die, probably an oversimplification, was Steve was the chaos, which is another way to say the energy. It's all this energy. And when they put so much bureaucracy in there, Apple completely not just lost its way, lost its relevance, and it just was gonna go out of business. There's no doubt about it. And so what they learned was, and we know this. I know it's self-evident, but it's easy to forget in the moment. I want enough bureaucracy, this guy said, that I'm able to capture at the maximum value that chaos. And he described sort of the tactics that they used to surround Steve so he could bring his full authentic self. And he did. Look, there's some maturation for sure, but they didn't want him to get so mature that he didn't recognize when he came back, the iPhone, the iPod, the iPad, like all of these things that the App Store over and over and over changed the world. They never wanted to be the leader by unit sold, but they wanted to be the innovators. And so they did that. So they managed that bureaucracy and that chaos. And so that's a challenge for us. A whole bunch of introverted engineers, a few extroverted, I don't know if engineer is the right word, but extroverts of us. How do we do that? How do we bring the chaos of the excitement with enough bureaucracy around high voltage and critical infrastructure that we can manage through this? And so when we think about how do we design for the future, I don't disagree that a lot of people are talking about this. It just seems to me, whether we're talking about modular or maybe that's the next place to sort of go with this, but how do we think then? Do we do this at the component level so I can make these interconnected changes without disturbing production, but I'm continuously able safely to meet the demands of the marketplace when we don't know what demands of the marketplace are going to be in 5 years?
Well, if everything goes modular, it won't be new because people have been doing it for a while. You remember the Microsoft trailers getting plugged into the spine of power and cooling and whatnot? They will have been viewed as pioneers maybe when everybody adopts that. I happen to think that there are a lot of reasons to think that many data centers will be built in that fashion, especially if you can build 80% or 90% of your components that are similar from one user to the next. And why not? It solves so many problems. And I don't think it's cost so much, but it saves potentially time, and it saves all this labor that we have a problem with right now. There are areas of the country that just can't get enough labor to build these things. Delays happening left and right. And people are talking about it, and very few people are doing anything about it. But I think, once again, a year from now, you're going to find a lot of companies jumping into this game, adopting modular for their own business. We just did, and I think we're early, but I think there are going to be a lot of people adapting to that or adopting that and just taking advantage of the opportunity that we see. This is part of my whole theory of I just don't like the concrete box. I don't necessarily like the big white, 50-foot trailer thing. I'd hate the ISO container look. I'm thinking about modular, like you don't even have to have an enclosure around it. It's just something that is designed. We think about modular like the inside out. It's not how much stuff can you cram in a box. It's what is your application, and what do you have to support that application in the way of chill water, in the way of power, in the way of network. And if you surround the application with all of the stuff and you're able to feed it in effectively, then if you want to put an enclosure around it, fine. If you don't, just slide it into a building. That's where I think some of this is going to go. And there's so many buildings out there that could be data centers. You just slide a module in the back door and piece them together inside.
Yeah. Well, I mean, Tony Grayson makes a whole data center that's a modular data center. There are plenty of people that do that. He does them for, if I remember correctly, like Department of Defense and others. Doesn't use concrete, doesn't use anything like that. It's all like you can basically drop them in from a C-layer, a heavy drop from a C-130
Sustainability is
or
one
whatever.
of the advantages, they say. But in the UK, Europeans are big into it.
But how do you balance then? Like one of the reasons why
Scale?
Yeah.
No,
so there's the, like, we want to be efficient with our resources and whatever. As you're describing this, on the one hand, I love this idea. I'm sure you've been doing this for a while. 10 years ago, before we got offended, what did a regular data center of any size look like? If you were to just come across a data center in the wild, what would be your physical, as you looked at it over the bluff?
Ago?
Yeah, 10 years ago. What would it look like?
Oh, I think 10 years ago, there were many, many purpose-built data centers, but they would be single story, maybe two, and tilt up and 10 to 20 megawatts.
Not particularly descriptive. You wouldn't necessarily
you
know.
wouldn't have a sign out front. No,
You wouldn't know
back then.
necessarily what it was. It might have a fence. A lot of them had fences, not all of them. But just sort of, it could be gray, could be white, whatever, but it'd be very plain, right? Nobody particularly cared what it was. I will tell you now, in many, many communities, if you bring in anywhere in the world, not just our European friends, or I don't know what it's like in Asia Pac or South America, I don't have any experience.
Yeah.
All over North America, that is certainly not one of our data centers.
You're thinking about what you've seen and not what you've foreseen, I think.
Okay. So what should we foresee?
Well, I just think there's some design element that needs to go into this, right?
Okay.
I think people haven't really imagined the future of the modular data center quite like it needs to be. Everybody, when you say modular data center, they think of the ISO container. It's I almost said a bad word, the stuff that was put out in the parking lot, and it didn't look very pretty, and you wouldn't want it in your city or town.
Right.
But you can make them look pretty darn nice, okay? You can make them look very nice. And I just, all I'm talking about is the way you build them, the applications that you build for. I don't think we know yet what inference is going to do. People are saying,
When you say inference, what do you mean by inference?
AI, the next step. I'm going to be trying to talk out of school here, but
That's right.
AI learning is the model
I'm
generating
training
tokens,
it.
right? Training your 30, 60 megawatts of campus environment, and then inference, they say, can be done with smaller scale data centers, and maybe to be determined whether it could be lower density data centers.
Right.
I think Jensen might disagree with that. If it could be done with high-density data centers, he'd probably like it to be done that way. But what I hear is everybody's talking about the campuses, the gigawatt campuses. Nobody's really talking about the 2 to 5 to 10 megawatt distributed platforms. And I'm not going to say that word that you're thinking right now.
Sushi?
Edge.
Edge.
Okay. Now, I didn't want to bring it up, but edge has been kind of a joke, right, in this industry for a long time.
Well, I don't know if it's a joke. It just is. I think everything's the edge. It just depends on the workload and your geographic location.
Yeah, that phone right there is the edge.
Right. To somebody for something, right? And so what the temptation is, and I get in, it's probably not worth belaboring because I end up in these conversations all the time. Usually what makes me feel better is when my buddy Phil Lawson Shanks over at Align and I have this conversation regularly. Just define it as it's either got some latency limit, the edge is wherever the work gets done, and that it has to be in a geographic location. It might have a latency requirement, whatever. It might be a size. I describe the edge as something that's of a certain size, however you want to decide it. But I guarantee you for a 100 megawatt facility in downtown Atlanta for 4 million people, it's the edge.
Yeah. And the edge will take lots of different forms. I was listening to a podcast on the way down here today, and they were talking about Waymo vehicles and basically calling a vehicle the edge.
It is.
Because it's got the model on board, and you can do all the learning or all the inference that you need from right there.
Right.
So I don't know where things are going to go. I do believe that the big concrete box is on its way out. That's all I'll say. But I would like to see what the next version of that is.
Now, do you think it's because, let me ask you this. So it's, I just had somebody on here the other day and we were talking about the envelope.
Yeah.
and modularity. And their challenge with the big box wasn't that it was a big box, because there's a spectacular level of efficiency that you can get.
Sure.
But what they wanted to see was, one, it doesn't necessarily have to be concrete or cement. Like, there's much more sustainable, better, in their opinion, ways to do this for all kinds of reasons. Like, you can assemble something in a factory, have it deployed and stood up. You don't have to do it on site and whatever. And the ability to make incremental changes as the workload inside that structure changes over time, and you want to contract it or grow it or whatever it is. It just is a lot more flexibility than this way that we've done it, to your point. Right. Not just the last 20 years, but the last 5,000 years. Like, this is a way to think about that differently. But to get an economy of scale, whether it's GPUs or CPUs, TPUs, used to be discovered.
Right.
Just like why they're making these really hot clusters, they have to be close together because of the network requirement. And so we're moving off of raised floor in most instances on a slab because you can't hold all the weight. You've got to squish them together, which brings its own challenges on getting the cooling close enough and enough compute distributed and all these other things. So people are rethinking that.
Yeah.
But they want an economy of scale, at least at the learning locations. But I don't think it's going to be limited to that. I think it's going to be a number of things. So it's not necessarily the big box or the little box. It is, how can I interconnect these components?
It's not the box at all. It's the stuff that goes in the box that matters. And you've been describing what I think I said earlier in the conversation, that the amount of electrical, mechanical, and network infrastructure that has to serve the gear that is there is so dense and so massive. To me, I think I wrote this in an article not long ago. To me, it's like building a machine, building an engine.
Yeah.
It's got to be carefully designed and coordinated and orchestrated, and the way it's laid out and the way it's installed. And it's just, there's no reason that can't be done more effectively off-site in a factory setting.
Yeah.
There's no room for a bunch of people to stand around and work in that area.
Yeah.
It's got to be prefabricated, and it's got to be fully engineered and coordinated up front.
Yeah.
And when it is, I think it'll be efficiently delivered and assembled on site. I may be 2 or 5 years ahead of my time here, but I just think that as the density increases, it's the way things are going to have to go.
Yeah. I like the machine analogy. I always think of it as like it's a motherboard. Mm-hmm. I got a chip in the middle that does all the work, and everything else on the motherboard is supporting the chip. The memory is doing it. The transistors, the capacitors, all these other things, they're supporting the work that's happening on that chip. And we build that on an assembly line, and we build the components in their own assembly lines, and then it comes together and gets assembled. And some of those components can be interchanged, the memory or the storage or whatever, and other components, once it reaches its useful life, you recycle it. Actually, you repurpose it more often than not, and you send it to whoever could use that workload that doesn't have quite the intensity. But that's the idea. I think we're going to see more and more of that.
I think I'm taking the colocation model down to the row, is what I'm saying. So where you build a building that's adaptable, I'm suggesting that people build pods that are adaptable. So the pod can accept a GB200 array or whatever that might be, and 1 or 2 megawatts. But if you choose not to have that, you've got all the pipe sized and the electrical equipment sized, and it can serve anything less than that.
Yeah.
But it can serve up to that. And so basically, that's what I think I'm telling you we should do is push that adaptability down a little bit further.
Right.
And maybe it's not the right thing to do for everybody, but if you have clients who want that infrastructure, golly, I mean, somebody's got to provide it to them. And I know we're a little ahead because nobody's deploying it yet. But if Nvidia is selling all these GPUs, where are they going?
Right.
They got to be going somewhere.
Yeah.
And they're already talking about the 600 kW racks. And, I agree with you. We have not seen massive amounts of these things deployed yet.
Yeah. Well, for sure. I mean, modularity, some would argue, is here. I see it even when you were sort of talking about this, like we have seen components of modularity within a data center for sure. It's talked about at least as often as on-site power or these other things, right? For all the other reasons. The other thing why I think one of the reasons why modularity is so important is if you're I don't care what size of the data center is, to store material on site or to manage through that, especially the logistics of bringing not just the material, but people coming and going from a site. Now you're trying to coordinate all these other things instead of, a pile of stuff. Instead of, look, just bring your thing in, snap it into place there, all things considered, it clicks in or however this works. And then you're out of the way, exponentially easier.
Yeah. And I think one of the reasons that I focus on this so much, kind of a defensive mechanism for me. I
Were you offended by a tilt-up wall at some point in the past?
I don't like concrete. No, I'll tell you a quick story.
Concrete guys.
I probably will tell this out of school, but no, I don't think anybody at Clark Construction is going to watch this. But I was at Clark Construction in the late 90s, and we started a thing called Clark Technologies. And I remember we didn't have any business. We just had this. My boss said, go find something to do in technology. And I found a data center customer. And I walked in there with a data center client, and there were people in the room who just said, nah, we don't want to do that. It's just single story, tilt up. It's all mechanical, electrical. We don't want to do that.
Right.
They were dirt and concrete people back then. Back then. They're really good at data centers today. But they reintroduced Clark Technologies 2 or 3 years ago, and they acted like it was the first time. But I think where was I going with this? I'm just, like I said, data centers are the concrete envelope or whatever the envelope is just there to protect all the stuff inside. And the stuff inside is what's meaningful to me.
That's kind of like saying it depends on who you talk to. I'm an organ guy. I'm all about the heart and the liver and the pancreas and the whatever. And the other dude's like, well, I'm a skin guy. Like if I don't wrap that wrapper in something that keeps the weather out and infection out and disease out or whatever, your organs aren't going to last all, it's a system, right? It's a system of systems.
And the data hall and the white space is the new frontier. It's the last component of the data center that hasn't been modularized or prefabricated. And there are going to be opportunities to do that.
Why do you think that's true?
Well, I was trying to describe it a little earlier. Imagine a typical data center 5 years ago, and if you tried to prefabricate the basket tray and the busway hanging overhead and a couple of, whatever racks and whatever, try to put that on a platform or something and ship it out, it would fall apart just trying to get into the building. It makes no sense at all. I visited a company down in North Carolina that builds switchgear and UPS platforms, skids, 50 feet long, 16 feet wide. They ship them down the road on a flatbed truck, and man, they just plop them down and hook them up and go. That was an eye-opener for me because I think obviously you have to ship it down the road unless you put a plant on site like Schneider is doing at Compass, I think. But if you can figure out how to build this maximum footprint of something and it happens to contain enough IT infrastructure and all the support systems that go with it to make it usable, then, that's a great model. I'm looking at the AI factories that Nvidia has shown us in their GTC presentations, and to me, they look perfect. It's perfect. It's you could build all this somewhere else and ship it in. I think it's kind of silly, frankly, that it's all overhead, the chill water piping overhead. But
why do you think that's silly?
Because why is it silly?
Yeah.
Because no matter how good you are, even the best contractors, the best installers, the best materials will fail from time to time. And I just don't know that you want gallons of water or PG-25 spraying all over your Nvidia Blackwell systems.
Yeah.
So I think it's temporary. I think eventually we're going to be putting that where it belongs, maybe below the cabinets, and then power can be above or below. I sort of think that all of it should be below, and then you could put it in one of those structural frames and ship it out, and then just plop the racks on top and you're done. That was sort of an idea that I had. I'd like to see that happen, but it has to be in the right application, the right building for the right customer. But I think that'd be a perfect prefabrication opportunity. And then you could just build them. You could connect them once they get out there. Everyone is of a specific size. It's perfect for the IT gear that sits on top of it.
It's so funny how, when data centers were first deployed regularly, my experience anyway, very rarely would you have any kind of raised floor. If you did, it was maybe a foot. Like it just wasn't a lot of raised floor space. Certainly not the university and other places. Over time, early 2000s, 36 to 48 inch raised floor. Mm-hmm. The weight wasn't really in the rack though. Even when we went to blade servers, there wasn't that much weight. And you'd have your low voltage, your fiber and your copper up above, and you'd have all your power below. When the conversations pivoted a few years ago to we're going to have all this weight, not just the liquid cooling weight, but the weight of the GPUs and this entire rack. We got to get rid of the raised floor. Just put it on the slab. That's the easiest way to do it. But that means, well, the liquid's got to go somewhere. Like all these connectors have to go somewhere.
Or we put all of that power and cooling infrastructure below that level of the data center, and you feed up.
So your perforations aren't coming from the roof up. In other words, anyway. So you have a data hall, and you have the mechanical infrastructure not in the white space.
Mechanical and electrical down below. It's
so they're
like
not
a
on
chip
the
plant, okay?
Right. So they're not to the sides, which is where they would go today.
Yeah.
They would go underneath, and they would penetrate up.
Right.
Is that the idea?
Yeah. And then you don't have to have the CDUs and the water piping and the PDUs and everything else in the data hall with the IT gear. You got the customer space, you got the operator space. And one group doesn't go in the space of the other. I think that's one option.
I can't wait to
worth exploring.
I think so. Not being a mechanical engineer or electrical engineer for that matter, spending a lot of time in data centers, though, when I have my electrical and mechanical outside of the data hall, the white space, my customers love it because they don't have any of my technicians aren't going into their space. In other words, if I'm working on the air conditioning for the apartment, I don't have to go into your apartment to do it. I'm doing it outside the building or in the attic or whatever. But whenever I go above or below something, it introduces an order of magnitude of complexity to service it. If I don't know why that is. It feels like if it's on the other side of that wall, because I can just walk to either side of that wall, I'm not kneeling and I'm not on a ladder, it's easier. Is that just my imagination? Or is it actually... Now, keep in mind, you and I are not in our 20s anymore, Steve. So maybe as a young man running, feeding electric wires up or down or cooling infrastructure up or down was easy. But now it feels like it's easy going horizontal, not vertical.
Maybe. But remember, you're thinking about a cloud data center. Multiply the power times 10.
Yeah.
And can you even put all that infrastructure in a gallery outside the data center? I don't know. Maybe you can, maybe you can't.
Well, right now they're just talking about putting it in there. Like that motherboard or that machine you were talking about. Like it's all on the board and that's the node, whatever that looks like, which, I mean, this is, for all intents and purposes, these things that we're talking about is sort of first gen or maybe gen 1.5. Like it's all happening in the last 4 years. We're figuring it out as we go.
Right. And it's going to be a terrible mess between now and 5 years from now when it settles out.
As we've already determined, an incredible opportunity.
Yes.
What are the risks that so the whole world will say liquid cooling. It's on-site is sort of overtaking it, but for the last 3 or 4 years, liquid cooling has been the thing that people talk about. I agree. Fantastic. What are the risks? What are we misunderstanding when we say liquid cooling? What are the risks we're not understanding completely? What are the opportunities we need to take advantage? When you think about that, how do you have that conversation with people?
I think there are tons and tons of risks with liquid cooling and so many different ways that people are attacking it. CDUs in the rack, CDUs on the floor, CDUs in the gallery, CDUs for the facility. These things are getting crazy. They're going from, a couple hundred kilowatts to 10 megawatt CDUs,
right.
And everything in between. So people are experimenting all over the place. And I think experimentation is good as long as you don't do it for your customer at scale and then figure out the experiment went bad. Well, I think
You wouldn't let your surgeon experiment on you, or your pilot. So I agree.
For example, there are materials that are being used today to distribute fluids that need to be pristine forever, and they may not be the right materials. They may not be installed properly to ensure that they're going to be lasting a long time without problems. And I know enough about this to be scared, scared that I want to make sure that when we do it, as we do it, we're going to do it right. But you got to talk to all the smartest people you can find, and even they will have different opinions. It's just a funny point in time right now.
Yeah. Yeah, I agree. One of the things I heard the other day was when we're talking about, it was actually a mechanical engineer, and it was sort of, I'm not an expert, so I don't have a way to evaluate I don't want to say the truthfulness, because I think he's a truthful person, but the, how accurate this assessment might be. But his point was, look, to cool a rack density of whatever it was intense, way over 100 kW a rack. You need pipe infrastructure. Let's just presume you got a liquid medium that works right. It's not water. Nobody wants water. It's going to be something else. The size of the pipes and the pressure of those has to be this. And I just want you to think about that. If the joints and this is a 24/7, 365. You can only presume that till we have more experience. Yeah. Maybe it runs 3 months or 6 months. I don't know. In when we were doing digital currency, if it failed, it was, you built these things in chicken coops. This is not that.
It can't fail.
It can't fail.
It can't be taken down for maintenance. It needs to run.
That's right.
Yeah.
You can turn it off when the job's done, but it has to run from start to finish. So here's the complexity you talked about. One, I'm presuming these interconnection points aren't going to fail. Like we think it's going to, but we haven't done it at scale. We haven't done it at that pressure for that long. And temperatures, all of these other things.
Expansion, contraction.
We don't know how the material is going to, we know what the computer tells us. But to do it, again, and so these are the things he's trying to introduce. Like we just say, well, we'll do it this many kW rack or that many kW rack. We're innovating. We're smart people. We're testing it. But this is the level of complexity. And then, oh, by the way, if you need to change something, we got something wrong, or hold on, we want to redo something. This is the level of complexity that we're dealing with. At least is that what you're thinking of and experiencing?
I think, it's all that.
Okay.
And you sort of have to oversize things to make it adaptable to the future. So everything you're putting in today has to be suitable for something that's coming down the road. It's a big expense, as you well know.
Yeah.
Some of these things add millions per megawatt. And so it's really hard to make that investment and think it's only going to be good for a couple of years. So, it's the tricky part to me is just the materials that you use, the methods you use to commission these liquid cooling systems, because you can't pollute the fluid, and there's so many ways you could do it. There's so many hands in this pie, right? There's the equipment vendor and the piping vendor and the mechanical contractor and the CDUs and the flex connection people and the valves, whatever. All these different people, commissioning authorities and owners who are providing equipment, and it's just it's a circus of people trying to commission a system. And if one person does something wrong, then who are you going to point the finger at?
Yeah.
6 months from now, when the heat sinks start clogging up because there's some kind of biogrowth or some kind of corrosion in, causing your Nvidia chips to overheat, you're going to have to try to figure out who was to blame.
Right.
And I find that challenging. I think that's going to be one of our big challenges. Because I do feel like there are lots and lots of contractors. I've been a mechanical contractor since 1983, and there are lots of great contractors, and there are lots of contractors that probably will make mistakes because they don't know how to do it the way that would prevent failures. I'm not sure that I do.
Right.
But I just think that there's going to be this spectrum of installation methods and quality, and those at this end of the spectrum are going to be bad, and these are going to be good. And unfortunately, the people that invested in that are going to have to rip it out and replace it one of these days. So, and that's bad news when you find out you have to do that.
Well, we've been doing it for 20 years with air. So if we're doing it now with liquid, like we're doing it with liquid. We are moving forward with
Yes.
liquid. There's no way to not cool these hot loads. There's not enough high performance CPUs to. For sure, there will be a hybrid mix of things. But you're in the liquid cool business as well. How do you? I'm getting tongue tied. Who do you think should own what? Like, is it the installer? And is the installer, are you also the commissioner? Is it the manufacturer? Is it the operator? Who owns it? Who's responsible for it? What do you think?
What I think. Well, the building owner, of course. They should be totally responsible. Because the problem's not going to arise until 2 or 3 years down the road. So, just so you know. I don't know. You can buy all this stuff from people like Vertiv, right? They'll give you the CDU, they'll give you the manifold, they'll give you the flex, they'll give you everything in between. They'll probably even put it in for you if you ask them to.
Sure.
Then you can point the finger at one person.
Right.
That's nice. But do you want to pay that price? I don't know. Maybe you do.
Yeah.
If you want to be cost effective, maybe you go with individual vendors and you just manage them. But then you have higher risk,
Right.
perhaps. And
a level of complexity of management.
yeah. And but there are different opinions on who, not just who's responsible for the installation, because some people in your business, I think, are saying, I don't want to touch it. I'll give you a CDU, but I'm not doing that stuff downstream of the CDU. You can handle that. That's like downstream of the RPP, or it's customer equipment, it's customer system. So you can do that yourself, and you can be responsible for it. But I think others are saying, no, it's ours. You know, we're going to give you an SLA, we're going to give you heat extraction, and that's part of our guarantee. And so, you know, it's just a different form of heat rejection.
Yeah. Well, look, when we were in, as a data center operator, we enter into agreements with our customers and say this is my level of responsibility, and we don't parse out. Have it in the past, even when they took managed services from us. If I'm managing their computer, I'm managing their storage, I'm managing their network. Like I built out to certain tolerances with my expertise, their network infrastructure, their compute infrastructure, their storage infrastructure, the backup infrastructure, and I assume responsibility for those things. This is a new world, but you know, we do business with Schneiders, the Vertivs, independent folks who are.
But they're learning too.
Sure, but everybody is. I suppose that's the thing, right? And so, but it's to have SOPs and MOPs and EOPs and people are world class. I guess what I'm soliciting from you is, as you imagine this, what do you think is, because we've got history of this with IT and others.
Yeah, I think the design will change, so we eliminate the potential for problems.
Okay.
You know, one example, I think, you know, it's the downstream of the CDU that scares me. It's the clean fluid that has to be perfectly clean forever. Somehow or another, I really liked it when the CDUs were in the rack, and then you could just run facility water to the rack and be done with it, and it didn't have to be crystal clear. And then everything within the rack was going to be a different fluid. But now when you're doing, maybe you eliminate CDUs altogether, and the whole system is clean all the way. I think the only thing holding us back from that would be the chips being able to withstand greater temperatures, and then you just put dry coolers on the roof, and everything is hot fluid going back to the roof, and you know, I don't know where it's going to go, Dave. Sorry, don't know, but I think we ought to find design changes to eliminate it. I'll give you one.
Okay.
I think when I was preparing for this podcast, when I listened to a couple of
your
your
prepared for this podcast?
by
Nice.
listening to your podcasts, I think you had a guest on not too long ago who may have said, and I hope I'm not getting my podcast confused, but who said that in Asia, maybe China, immersion cooling is a thing, right? That's
the thing, if I remember correctly, right?
And look at what we're doing. We could have a tank with servers in it and a simple loop that doesn't have to be pristine going out to the heat rejection system, and that'd be beautiful. But no, we got to complicate things. We got to run this fluid out to the chips and actually push the water into the rack. And we're doing this because the IT hardware people haven't embraced immersion cooling. We're sort of at their mercy right now. We have to do what they're willing to do.
Right.
And if they're not willing to accept immersion as a solution, then we have to adapt to their will.
Yeah. Well, I think it also, as part of that conversation, it was, I'm in my inbox going to fill up with hate mail from all the IT people. Thank you very much, Steve. But it was the manufacturing that was available, the supply chain that was available. Like he walked through why, or maybe it was she, I can't remember. I've had so many on now, but I do remember that conversation. But these are the reasons why, and there are winners and losers, and it's not always clear why, from a technology perspective, why one technology or the other, because I was trying to learn myself, still trying to learn, not an expert in this area. But it is, one of the things that we keep coming back to that I think is regular is, right now today, I need to deploy electrons that do something. And based upon whether it's my geographic proximity, the technology that's available to me, et cetera, what is the best way, the most reliable, affordable way to do that whoever my end customer is will accept and agree to? That's the challenge. I have no dog in the fight. Immersion, back of the rack. No.
I don't care either, frankly. We've been around immersion for a while. I don't love it. I don't hate it. It's just there. It's another solution.
Yeah.
I'm not pushing it. But I do think that some people will tell you that immersion offers a better PUE.
Right.
So if that's a fact, then maybe the hardware people ought to get on board.
Yeah. Here's what I've learned the hard way many, many times.
Yeah.
It's the total cost of ownership. And somebody will say, oh, fair enough. So you're going to get free energy, or you're going to get these other things. And in this window, in this sliver, it seems to solve all the problems. Absolutely. It's like two kids at the sack of suds. Do you ever remember the sack of suds?
I don't know.
Do you ever see the movie My Cousin Vinny?
Don't remember much about it.
Long time. Anyway, so the actor comes on, it's Joe Pesci, and his nephew and his buddy are accused of committing some crime. They're driving a green car with a white top, and they came into the sack of suds store, and they committed this crime, and all the people saw it. These kids didn't do it. And so the whole premise of this movie is they go through and they say, you get these apparent variables, but come to find out, as unlikely as it is, it wasn't that those townspeople were trying to be incorrect or wrong. From their perspectives, they didn't see the whole story. And as it turned out, it was a couple other people in a very similar scenario actually committed the crime. It's a very funny comedic thing. As I've learned through these conversations and 15 years of being an SE out there on the floor, why don't we just do this like this? Like, if we would just do this like this, well, here's the total cost of ownership like that. Yeah, it feels like in this swim lane, that would be easier and more dynamic. But in maintenance mode, this is the problem.
Oh, yeah.
Or whatever. That's what I mean.
It's the maintenance. People object to the sliminess, the spillage, the
I don't know.
Safety. I don't know either.
I don't know enough of it. But and I'm not picking a winner or loser either, but I hope that we have an innovation cycle robust enough that whether it is immersion or whatever it is, that we have the ability to adopt over time to, look, I'm taking raised floor out of I never thought that would happen, out of so many of our builds to accommodate different workloads.
Well, like I said, I think we're going to see 50 different options because everybody's looking at this as the gold rush again. You know, this is a 2025 version of whatever it was back then. Everybody's coming up with a way to get rich quick.
Yeah. You don't think they'll just like we standardize on a rack, we standardize on a U, we standardize on a electrical outlet circuit breaker, like we standardize on this stuff.
I think we're changing that. That's all going out the window. It's the latest thing that you're hearing about, I'm hearing about, DC power in the rack, you know. It's going to be different. You can't do, it's not going to affect 98% of the deployments out there. It's going to affect those that are really intense. That need those Vera Rubins or whatever they're called. Yeah. But, there are changes in the works. Yeah. And they're going back to DC power. Yeah. I heard people talk in this recent OCP call about 800 volt DC. I don't even know how that works, but I'm looking forward to figuring it out and watching people adopt it. Yeah.
We'll see. We've deployed over time heavily managed but DC power plants for one reason or the other out there. But we'll see. I just think there's a lot going on now because we're trying to harvest in this unprecedented time. We have nuclear scientists on here talking about, like, who would have thought 10 years ago, 5 years ago, the small modular reactors, 10 or 12 years away, but that there would be so much conversation about nuclear in general, or SMRs or micro, right now for these requirements.
Well, that's another thing that's going to happen. I think the integration of power with the data center, right?
Yeah.
People are already talking about BYOP and having your plant behind the meter or next to the data center.
Right. BYOP meaning bring your own power.
Yeah, bring your own power, right?
Yeah. I just
As
said that
opposed
because
to
so many of
BYOB,
our audience
right.
is like, what's a BYOP? I don't want them
Most
out there
people would
Googling.
understand bring your own beer, but bring your own power. Okay. But energy and data it's just a different form of energy.
Yeah.
I think they should be long-term. I think they should be integrated. They should be all part of the same apparatus.
Again, another level, as we're learning, another level of complexity. The regulation around a data center is one thing. The regulation around energy, and within energy, the regulation around nuclear energy versus natural gas versus renewable, vastly varying.
We will live long enough to see it, though.
No,
I'm
I
pretty
don't
sure.
disagree.
Yeah, it's gonna
I just mean, as I have these conversations, depending upon the point of view of the person that I'm talking to, and some are like me, I tend to be pretty optimistic and I'm really excited about a particular way and look at all these opportunities. And then I will inevitably get somebody on that says, fair enough. Is it going to be on your site? So it's wrapped up in the same piece of land? Because here's what happens when they have to do an on-site inspection. If they find a problem, everything connected to that land runs into this, and you don't have that problem now. So is it adjacent? Do you share it with other data centers? Like they'll just start with, we're nobody saying no. A data center has to have reliable, safe, affordable power always, has to be connected or it's not a data center, and it has to be secure, physically and logically secure. If it doesn't have those three things, whatever else it is, it's not a data center. I completely agree. As we're having these conversations and we as the industry, I as in my organization, as we work through them, these are the things that we're trying to be equally serious about. We're really serious about designing, building, operating, maintaining data centers. We spend a lot of time learning those things. And so sometimes people come in and say, well, why don't you just do this? Well, because it looks like it solved the problem. But in the scheme of things, we're not the people of no. We constantly innovate. But here's the challenge in the whole pieces that we're trying to solve. I'm fascinated by the idea of bring your own power. Whether I own it or I partner with somebody to do it, and everything from firming up intermittent power, geothermal, natural gas, all of it, nuclear. Like, I believe in energy sovereignty. If we want to know what our nation best interest for our country for the next foreseeable future within our borders, we need to have our own energy. I completely agree. But as I have these optimistic conversations with folks, they're like, well, here's the complexity of that. Here's the opportunity, but here's the complexity.
But haven't you noticed in the last 6 months when there may have been a lot of objections to nuclear power, a lot of those objections are more silent today? I just feel like there is just an assumption that it's going to happen today.
Yeah.
I feel like people are just realizing that in order to achieve our AI goals, achieve our AI supremacy, in order to be what we can be, we can't do it with coal. We can't do it with solar. We can't do it with wind. Maybe we can get there as a bridge with gas, but eventually it's got to be something clean and something really powerful. It takes up less footprint, and maybe it's nuclear.
Yeah.
Maybe there'll be some other invention between now and then.
My favorite topic, which always makes me flinch, which is a phrase called future-proofing. I don't know how we future-proof when, we're really not sure even what the next 5 years looks like, much less the next 10 years. So if you're in your role, in your organization, as you're imagining, well, first of all, what's the future for you? Do you think in 3-year, 5-year, 20-year? How are you thinking? What do you want to be designing to that you feel? I don't mean the micro solution. I just mean our horizon needs to be at least this, or we're wasting our time.
Thankfully, I don't have to think about that. I ask customers what they want.
So what do they say?
I think everybody's going high performance, high density. I just have, That's where I'm focusing my attention.
Now, do
okay?
you spend a lot of time with the Fortune 1000, or is it primarily the hyperscale?
I'm spending time, actually today, more with OEMs, the IT hardware people who are really focused on Nvidia. That's where their gravy is these days.
Right.
I guess they can sell a rack full of standard servers for the cloud. They'd be happy, but what they really want is they want that, big array of Blackwells.
Right.
I know. I'm excited by that, and I spend a lot of my time and attention trying to figure out how to support that coming requirement.
Mm-hmm. So what's their horizon? Are they in a 24-month cycle? Are they in a 48-month cycle? What's that cycle look like?
Just in a total disarray. I think. Think about it. Nothing really changed for 20 years.
Yeah.
We could use the same data
Or
centers.
longer. Yeah.
And things are changing in two.
Right.
Who knows? It's not just Nvidia too. I'm sure other, AMD and other chip manufacturers are thinking the same thing.
Mm-hmm.
I'll go back to my previous statement. I just think performance will dictate. And if you can get better performance out of a hot chip, you're going to use a hot chip over a cold chip. So you're going to have to adapt to hot chips. Mm-hmm. And lots of hot chips. Yeah, you explained a little while ago that they all need to be bunched together. Mm-hmm. And if that's the case in the future applications, then we're going to have to figure out a way to get that heat out.
Yeah. Well, I almost wonder if modularity will be something like this. It's self-contained, self-contained once upon a time meant a mainframe and you connected the terminals to it or whatever it is. You go from distributed to centralized, distributed to centralized. If it is almost Tony's vision, so they'll come, if there needs to be a big cluster. So I'm the third largest or fourth largest insurance company. I want to take advantage of GPUs. But I'm not doing massive training deployments. I'm going to do mini training, and most of mine's going to be inference. So I'm taking this stuff that's been trained and I'm putting it to work, right? There's a Alabama or Dallas or whatever has just had a hurricane or a tornado breakout. And I'm dispatching a couple adjusters with drones and with all of this other stuff, and they're evaluating so I can get help to people and their money and their construction checks and whatever, suppliers moving quickly. So I'm trying to multiply people. I'm going to do that through HD cameras, and I'm going to do it through technology and all these other things. But I need my AI to help me to evaluate what's going on, cross-check it, cross-reference, prevent fraud, both in the destruction and in the distribution of funds or whatever. So all these things, I see a future for all of this stuff in this one little application. So it's going to come back to this level 3 or level 4. Maybe some of them use somebody's cloud service to do that. Maybe some of them do it themselves. We're in conversations like this all the time. So when it comes back to them and their node, I wonder if these OEMs that you're talking to are going to say, I can sell you a node that looks like this. And to a data center operator like me, it's easy peasy.
Back to on-prem.
I don't think it's going to go. But here's the challenge with on-prem. Maybe, certainly possible. I just don't think that they don't have the expertise to handle the on-prem. That's not what they're telling us. I see it landing at, for sure in some instances, but where they want to leverage the larger, they're going to ship it to a facility like ours. We're going to snap it into place. And it's their own super secure, containerized thing. We could put them multiple together. We could just stand alone.
If I were buying stock today, I'd buy stock in QTS, except I can't.
You can't. We're private.
Well, when I can, maybe I will, because I believe in your company.
Yeah.
I believe in colocation.
Yeah.
I believe in data centers. I believe there are going to be many, many different kinds of data centers.
Yeah.
To me, there's been really a couple of different flavors in the last few years.
Yeah.
There's been the hyperscale campuses of their own where they do experimentation and whatever they do. Mm-hmm. And then there's been the colo world. And the colo world was largely kind of a, there was differentiation, but not a ton.
Right.
I'm sorry to say. There's just everybody was able to offer a data center for everybody.
There wasn't a lot of differentiation in the shape.
Yeah, the shape and the capacity.
And what the differentiation was the service that you got from that.
Yeah, probably so.
Yeah.
But when I started doing data centers in the late 90s, everybody was saying 2N plus 1, 5N, whatever. It just had to be so reliable. Right. The power was everything. It could never go down.
Right.
And after 4, 5, 6 years, I think it kind of shook out and N plus 1 became okay.
Right.
And so everybody's reliable today.
Right.
Reliability is just kind of a given. You don't have to impress people with your one-line diagram anymore like you had to back
Yeah.
then.
Yeah.
Anyway, I just think that when it comes to cooling and IT support, there's no standardization anymore. There's just a massive amount of flux and confusion, and I think when we do standardize, we're going to standardize in a bunch of different ways. I think we're going to standardize on the high-performance pods and the medium-performance pods and low-performance pods, the big campuses, the edge, the whatever it might be, the inference, the learning. I just think it's going to be a massively diverse business.
Yeah.
And I don't know. I think that's a good opportunity for folks like you to get into other parts of the business. But, I mean, you're pretty busy now. You probably can't get distracted with all those other things.
Hard to say. We got a lot going on, and we have a number of innovation groups. I'm not gonna. I'll get in trouble if I start going through the secret sauce stuff.
But what I hear sometimes the big
Lean
guys
back
are,
up to your mic.
the big guys are now saying we can't find 2 megawatts or 5 megawatts where they want it because vacancy is negligible today. And so-
Within a data center.
Yeah,
you
within
mean?
a data center. They need to be in, pick a city, Baltimore, 2
Sure.
megawatts. Where do they go? Maybe they can't go anywhere.
Right.
So,
Temporary problem.
you think so?
Yeah, for sure. That's take away megawatts, change it to kilowatts, and add a couple zeros. I can't find 500 kW.
Yeah.
I couldn't find 50 kW. I couldn't find 10 kW. And I'm not trying to minimize it, or minimize it, not minimize, at all. You and I have been doing this for a long time. Here's what I can't find. And I'm not saying this isn't unprecedented. It is unprecedented. If our customers could do it themselves, they would do it themselves. The reason why organizations like ours get involved is because it's hard. It's hard. And they're special, very super unique, one-off things, they do themselves. Everything else, they outsource to an organization like ours because it's hard, and we'll do it for them. But whatever that is, whether it's in a suburban area like you described or a remote area or whatever, one of the other big pressures, I just had a conversation with someone about this the other day. One of the largest robotics makers on Earth, autonomous vehicles on Earth, who would you imagine it is right here in North America?
Tesla.
John Deere.
Really? Oh, that's interesting.
Isn't that interesting?
Yeah.
And do you know how much connectivity and opportunity, because this is all like to send robots up and down fields
We're
or
gonna convert barns into data centers.
the combine or whatever, or just drop one of these self-contained nodes back to our conversation about what the edge looks like. I need it near the workload to do this thing. And one of the reasons why people are struggling with farms is not because the corporate farms only are driving them out. It's because none of the kids want to be farmers. They want to go do something else. So in this vacuum, in this challenge, you bring in low Earth orbit satellites, or you bring in these other things, you bring in one of these nodes that can connect to them. It's talking to these machines that are using HD cameras to do all this other stuff. You could train up locals who are interested, whether they're new citizens of the United States or legacy family, whatever. These are the opportunities, I think, or people that are sick and tired of living in Baltimore and they want to live on the outskirts of Tulsa or whatever it is. But these things are coming together and they're innovating, and those nodes can fit in a big data center or a little data center. That's the really cool stuff that I see. But I do think there's standardization. Right now, we're sort of all making the sausage, but 98% of it is still pretty normalized. Could things go back to on-prem? Maybe. I suppose
I don't
it's
know.
possible.
I'm not suggesting it.
But I don't see universities saying, hey, let's build out more data centers. What they're saying is let's build out more classrooms and just keep outsourcing to the cloud, or keep outsourcing to that building that's expert in data sovereignty and whatever. I don't even want to fool with it. I want to fool with whatever else might turning people into electricians or whatever. It's I just am curious about this future-proofing idea that I keep hearing people talk about. I'm like, well, I don't know what that looks like because it's so it might be easier to describe in a few years, but right now it's so disruptive. I think the future is to stay curious and stay engaged and stay innovating, and to your point,
Stay
listening.
nimble. Yeah. Even IT is changing when you talk about some of these AI learning models, and you're now putting UPS on the cooling systems and maybe not UPS on the power systems, on the critical power, and you're using generators or not using generators, using batteries in ways that people weren't using batteries before. Gosh, there's no standardization there yet.
Yeah.
I don't even know if everybody understands what's going on there yet.
Yeah.
But it's really fascinating.
What do you mean
stuff.
you don't think they understand?
Well, the use of batteries at Elon Musk's data center in Memphis, I think it was one of the first times I've heard of batteries being used like that. And honestly, I don't even know exactly how the one line looks in his data center. But
Okay.
I feel like we're not just using the batteries in a UPS application now. It's to help the grid. It's to help prevent the load from affecting the grid.
Right.
And if things continue to act wacky like that, we're going to have to use a lot more batteries.
Yeah.
Instead of generators, maybe you just use batteries.
Right.
So the batteries are constantly being charged off the grid, and then you never have to have a generator.
Yeah. Where I thought you were going with the UPS conversation was, it's not long ago, maybe just 2 or 3 years ago, we really thought we'd be, if not completely eliminating UPS from all of our designs, greatly reducing. Like, who wants to have yards and yards of generators, rooms full of any kind of UPS infrastructure, kinetic, static, batteries, whatever it is. But when we began introducing liquid cooling again and CDUs and all these other things, and the money in that rack, so I needed to make sure that this cooling infrastructure, the mechanical load was never on UPS infrastructure before, life safety and the compute. And now we're looking at changing all of that, if not already changing all of that, back to future-proofing. It's where the risk is.
I think you just answered your own question. That's a better answer than I could have given you. So.
Well, I use more words as I usually do.
Yeah. I don't know what the future holds. I am looking forward to the future and can't wait to participate in the future. And maybe we can even affect the future in some way or another.
When you come back on next conversation, what do you think we're going to be talking about? Are we going to be talking about some of these?
Hopefully something I know something about. There's so many things I don't. Start going down that power road.
Yeah.
That's not my area. But
what do you think will be one disruptive thing we have really gotten way better handle on, or a new idea that might get introduced that we're really not spending time on now? Anything you can think of? Like, what do you think we might have firmed up more? Okay, so we're, for sure, UPS on mechanical, or GPUs more distinguished from CPU, or, where do you think as an industry, you go to a lot of these events, you hear a lot of people talking.
Yeah, I don't hear many people prognosticating quite like that, though. I kind of think that one day data centers will be like automobiles. There'll be different models, and there'll be some standardization amongst everybody. You'll be able to pick what you want for the right application. It'll be shipped off the line. You use it how you want to use it. If you want a train and you hook them all together for scalability, you buy different train cars and you put them all together. But I think we have to see some standardization. It's just too crazy right now. But we're still several years away from that, unfortunately. And maybe we won't see it until Nvidia stops. And they're not going to stop.
Yeah.
Would they just stop bringing out the new stuff? It would be nice if they just take a break for a couple of years.
Yeah. Would they just stop bringing us all this opportunity and capacity?
Yeah.
I don't want them to stop. I love what they're doing. And I know you're being sarcastic.
Yes, I am.
I can't wait to see the other folks come alongside, respond to the challenge, and bring, whether it's, I've got to meet Jensen one time. He really lives up to the hype. Like, he's a really interesting guy, at least in a casual get to know him. So it's really cool.
You should invite him to your podcast.
Well, maybe my bosses probably be terrified, but really cool guy. And but his team, like Jeremy Rodriguez, and there's so many of these folks over there that are really just the innovation that's going on, not just in the chips, like across that organization. That's great. But I also, over time, people leave and they start they germinate their own things. And that rises up to help sort of either fill in gaps or bring other competition, maybe even in that main focus, and we all benefit. So I can't wait to see that. And then the other piece, we didn't talk about it today. We're not going to start a whole nother podcast. We'll wrap this one up in a minute. But we've talked primarily about technology today and how we want it to standardize and innovate. Something that was not in the news 4 years ago was a community reaction to a data center coming into their community. And it is in the news all the time now. I think there's a lot of misinformation that I think I know. And so one of the skill sets I think that our industry is going to continue to develop is the ability to evangelize when we go into those communities, to sit down and listen, really understand before we try to be understood, and to not lead with economic benefit or tax breaks, which are spectacularly helpful. But I don't think that we serve ourselves greatly when we go to an environment that's trying to figure out who and what we are and what's real and what's not. But to the degree that we can, I think that's be a soft skill that gets developed in our industry, or people aren't going to stick around, to get in and connect and find those places that we can work well together and be able to have that line of communication. It's not a technology thing, but I do think it's going to be an important thing for all of us to get better at. Well, Steve, we talked about a lot today. I appreciate it. I think if we go anywhere else, we have to start a whole new podcast. I don't know if my bladder would handle that. But, thanks for coming on. I really appreciate it.
My pleasure. It was really nice. My first ever. You're my first.
You did great. I'm glad I was there. I'm glad I was there for the experience. Thanks for coming on.
My pleasure. Take care.
Hey, everybody. If you enjoyed that conversation, click the like. And if you loved it, click the subscribe. We'll see you next time. Have a good one.